It begins with energy. Energy is vital to the growth of our nation's economy. A healthy economy means more jobs and growing income. But even with successful energy conservation, the need for additional energy in America and throughout the world is increasing. In the next few minutes, we're going to tell you about something important to you, me, and our entire nation in the decades to come. It's about an energy program known as the Advanced Liquid Metal Reactor Actinide Recycle System. Since the oil crisis of 1973, our economy has grown by 50% and our population has increased by almost 20%. We've built over 20 million more homes and we operate 65 million more vehicles. Long-term projections of worldwide energy consumption show a five-fold increase in global demand for energy in the next half-century. The source of energy most widely used in the production of goods and services is electricity. Electricity has become a critical element in the American quality of life. It's closely coupled with population growth, industrial competitiveness, and jobs. And electricity consumption in America is projected to continue to grow steadily, requiring nearly double the current electric power capacity by the year 2030. To address this need for clean, safe, and economical energy generation and use, Congress passed, and the President signed into law, the National Energy Policy Act of 1992. Conservation, natural gas, hydropower, clean coal, and renewable energy sources such as solar and wind must all play a role in meeting our energy needs, but each has its own limitations. Nuclear power, which currently generates 22% of the nation's electricity, is particularly suitable for pollution-free, continuous, large-scale electricity generation, and it is recognized as a significant part of our energy mix. The Energy Policy Act supported the evaluation and development of a wide range of electrical generation options so that the best choices would be available to meet future needs. The Advanced Liquid Metal Reactor Actinide Recycle System, or ALMR, is specified by the Act as one of the nuclear power options important to the country. So what is the ALMR, and why is it an important option in the energy mix? The ALMR system is an advanced energy option being jointly developed by U.S. industry and the Argonne National Laboratory under U.S. Department of Energy sponsorship, with support of several international participants in Japan and Europe. It combines a passively safe, modular reactor power plant with proliferation-resistant fuel. The National Energy Policy Act calls for demonstrating the technical and economic feasibility of the ALMR and its fuel cycle by 1996. Based on these results, Congress and the Department of Energy will then decide whether to proceed in partnership with the private sector with prototype construction leading to commercial power production by 2010. The ALMR's adaptability is unique among the major power reactor concepts in that the plant can be designed to burn the long-lived radioactive products from spent light water reactor fuel, to destroy weapons plutonium, or to extend energy resources. The ALMR system is also responsive to the concerns and needs of the public. It generates energy safely, it is projected to be economically competitive with other domestic energy sources, and it is environmentally clean with no greenhouse gas emissions to the atmosphere and no contribution to acid rain. Central to accomplishing these objectives is the use of an innovative fuel which enhances passive safety characteristics and is coupled to an economic, proliferation-resistant, and compact fuel cycle. And further, significant improvements in nuclear waste management appear feasible. The recycling in the ALMR of the long-lived waste products from current reactors would reduce the number of waste repositories by a factor of at least 4. Since the long-lived actinide elements would be almost completely destroyed, the toxicity hazard of the waste would drop to the level of natural uranium in just a few hundred years, compared to hundreds of thousands of years for the unrecycled spent fuel. The recycle system would pay for itself by generating electricity. and evaluations show the ALMR to be cost competitive with current electricity generating sources. In simplified terms, the ALMR could be considered as a non-polluting incinerator which converts toxic waste to energy. The design concept is like this. The passively safe reactor power plant design uses factory-fabricated reactor modules as its basic building block. 6 reactor modules are arranged in 3 identical 600 megawatt power blocks, generating 1,800 megawatts of electricity. Smaller plant sizes of 600 or 1,200 megawatts can be built by using only 1 or 2 of the standard power blocks. The plant components are also modularized and factory fabricated. As a result of this innovative factory fabrication, the construction time, economics, and quality control are improved. The design includes many other innovative features such as seismic isolation, underground construction, and reactor pumps with no moving parts, and builds on many years of successful and safe liquid metal reactor operations in the United States. An important milestone of the ALMR program was the completion of a review of the basic design and safety performance by the Nuclear Regulatory Commission. In January 1994, the NRC issued a pre-application safety evaluation report which concluded that no objections or impediments to licensing the ALMR design have been identified. As recognized by the National Energy Policy Act of 1992, the unique and significant potential of the ALMR system in meeting future energy needs merits further testing and design. The National Resource Council Committee, sponsored by the National Academy of Sciences, also concluded that the LMR should have highest priority for long-term nuclear technology development. Utilities and the technical community recognize the significant potential of the ALMR to reduce the need for additional nuclear waste repositories, and the experts agree that the ALMR program will help, not hinder, efforts to control proliferation. The next step is the completion of the preliminary design of the ALMR in combination with the fuel cycle demonstration by 1996, providing important input that will help us to formulate and implement a solid national energy policy. Continuing the funding of this project will make this possible. The advanced liquid metal reactor is an important energy option to carry into the 21st century.